Hello everyone. The topic we are going to do is mechanics, but the first lesson is change of rates, which is the velocity and acceleration in terms of displacement. Now we are going to use symbols of x and x dot as a velocity and x double dot as an acceleration, and of course x is the displacement. Okay. And let's have a look at the first formula for this one. Acceleration has been defined as the rate of change of velocity with respect to time t. Okay, so acceleration equals dv dt. That's not too bad. The next one, and to solve situations where acceleration is a function of displacement rather than time, which requires the following alternative form for acceleration. As you can see here, the acceleration is in terms of t, and here in terms of x displacement. Okay, so now this is the proof to get this expression, but let's have a look. This one is not quite up to this proof, but it's useful to find out that acceleration is dv dt. Okay, so acceleration equals, we are going to have this equals, now what happens is, and this is a good skill to learn, so d of half v square over dv times dv dx is exactly same as this. How? Because I'll just cancel the dv and I will get back to this one. Okay, but this we can actually differentiate of the half v square in terms of v. It's half times 2v, right, which is v, so that itself is v, and I'll bring this down. Now v in terms of t is dx dt, and then also that brings down, and if I cancel the dx, I'll get dv dx. Okay, so that's we can say we can write it as a dv dt. Another one is, now this is what we just want to prove, that in terms of x and a v square over 2. So acceleration is dv dt, as we proved that. And I'm going to use a chain rule. I'm just going to go dv dx, dx dt. So if I cancel the dx, I'll get back to dv dt. So we're just creating an extra term to manipulate. So that's as it is. Now dx dt is actually velocity. Okay, and velocity we can rewrite as a d of v square over 2 over dv, just like here. Okay, so I'll just have a look at if you don't understand, and I'm going to bring this down, and that I'm going to use another expression, and what happens is I'll cancel the dv together, I will get this as required. Okay, so as you can see, we have many options. Okay, many options to use acceleration. We got dv dt, we have these two expressions with in terms of x, and also this one I'm not going to talk too much about. This is the for simple harmonic motion, which is the next video, and this one is the velocity, which is dx dt. So now we have x dot and x dot dot as a functions of t, and x dot dot and a v squared, right, as a functions of x. We got all of those, and I'll just give you a bit of a little reminder of different ways of expressing acceleration and velocity. Now if acceleration depends on time, we use the dv dt, but if it depends on the position, which is x displacement, we have options of 2. Okay, they both are in terms of x. Okay, so let's start the questions. First one. The acceleration of a particle is given by a equals 15x squared plus 2x minus 6, where x is the displacement. Find the velocity when the particle is 3 meters from the origin if initially the particle is at the origin and has velocity minus 2 meters per second. Now I'm just going to underline the key words here. So that's the velocity v, or we could say x dot, and that's particle 3 meters, so x equals 3 from the origin initially, which means t equals 0, and particle is at the origin, so x equals 0 as well, and initially, and the velocity is minus 2. So initially, when t is 0, x is 0, v is minus 2. Okay, so we need to, basically, questions like this, what is the actual question asking us? Find the v, velocity, when x equals 3. But to do that, we need to find the equation for the velocity, okay? We got acceleration equation, but we don't have a velocity equation, so we need to find the velocity equation in terms of x, y, because we need to use x equals 3. So no use for in terms of t, because we don't have any time here to use. And then when you find the equation of velocity in terms of x, and then you substitute x equals 3 to find the v. Okay, so that's the question we have to deal with. So we have options, right? We have options, 2 options for in terms of x for acceleration. We could have v dv dx, or okay, so we got some of those v squared over 2 as well. So I'm going to use this one, because if I use this, eventually, have a go at it, eventually you will get v squared over 2. So because I know that, I'm going to use this. Okay, so let's have a look. I'm going to have and also that equals to this. Okay, so I'm going to integrate both sides. So if I integrate, this will cancel out. So I'll get, and I'll integrate this side. Don't forget the c, because we don't have limits. Now we have to find the c. So the condition we had was initially when t equals 0, x equals 0, the v was minus 2. Okay, so we're going to use that to find the c. So what will happen here? So I'll get c equals 2. Okay, so my equation for the velocity will be, I'm going to actually change this one, 5x plus 2. Okay, and I'm just going to times by 2, double all of them. Okay, so we got velocity equation right now. So we need to find the v when x equals 3. So what are we going to do? put it into the equation here. So 10 times 3 to the power of 3 plus 2 times 9 minus 12 times 3 plus 4, you will have 256. So therefore, V equals plus minus 256, which is plus minus 16 meter per second. So my answer is V equals plus minus 16 meter per second. So it could be positive, it could be negative. Okay, so that was too bad. Next question. An object has acceleration a meter per second. Ooh, I made a mistake there. Meter per second squared, because that's acceleration, isn't it? Yep. And then given by the a equals v squared minus 8 meter per second squared. Yeah, that's right. Where v meter per second is the velocity of the object when it has a displacement of x meters from the origin. Find v in terms of x, given that v equals minus 3 meter per second and where x equals 1. So this is what the question asking us to do. Find the v in terms of x, okay? And when v equals minus 3 and x equals 1. Okay, so we definitely have to use the derivative with the in terms of x, isn't it? Okay, so I have option 4, v dv dx, or I have the other one, d over dx and v squared over 2. So I don't know. I think I'm going to use this one and see how I go with this. So v dv dx equals, because that's the same as that was given in the question. And then I'm going to move this v to the other side. And I'm going to flip this. And move this one to the other. Now I'm going to integrate, okay? Because I want this to be in terms of x and with a v. So I'm going to go integrate both sides. So dx equals. Now I'm going to have to do something to make it log. Okay, so that will be x and half log, oops, v square minus 8 plus c. So we don't have any limits, so we got c. Now it doesn't really matter if you put absolute value there, because ln you can't have a negative, so it has to be positive. So, but here it's going to be positive, isn't it? How do I know it's positive? Because the v was minus 3, so if you do that, it'll be 9 minus 8 would be positive. So I'll just put it in the brackets. But to be safe, you could just put absolute value in there. Okay, so I'm going to find the c when v equals minus 3 and x equals 1. We need to find c. So when you do that, 1 equals half ln 9 minus 8 plus c, because I put v as a minus 3, square it. Now ln 1 is 0, so the whole thing's going to be 0. My c therefore equals 1. Okay, so that's not too bad. So let's rewrite my equation here, and it will be x equals, oops, x equals half ln, I might just put brackets and plus 1. Now since I've got the equation, all right, but problem is we need to find the v velocity in terms of x. So this is not it's x in terms of v. So I need to, well, move around. So I've got to move that one to the other side. Okay, move this one. And then times by 2. Okay, that's not too bad. Now I'm going to take e exponential to cancel this out. Okay, and I'm going to move 8 to the other side. Okay, and then v equals plus minus. I'm going to put 8 at the front. Okay, now, but what was a v? V was minus 3, wasn't it? Was a negative. V is negative. So therefore, v equals meter per second. Okay, so that's the question. So please have a look at watch it more than once and have a go at the questions by yourself and see how you go with it. Okay, well done.